Today's section is section 4.2, which is relations and functions. And so we're going to identify functions, find domain and range of relations and of functions. And so we're just going to look at what these are and how these relate to the graphing that we've done so far. And so we can talk about a relationship. Now we have already learned that we can show relationships by graphs. And that's what we did in section 1, is that we looked at some things and we said, okay, well, we have age and height and age and weight, and all these things are related to each other, and we call that a relationship. But we can also represent relationships by points. And so points on a graph basically represent a relationship between those two things. And from what we know is we know that these are called ordered pairs. And if we look at this, what this means is that all ordered pairs are x comma y. And so this talks about the relationship between x and y. And so when I have an x that's related to some y value, even though it might not be a direct relationship, they're still related to each other because they kind of go hand in hand. We call them ordered pairs because they come in twos, and also because of this idea that they are paired together in such a way and that they have some kind of relationship to each other. There's some meaningful relationship between the x and the y that we can actually take apart and we can actually understand. And so if we look at a way that we can represent relations, as we call them, it says in a scoring system of some track meets, first place is worth 5 points, second place is worth 3 points, third place is worth 2 points, and fourth place is worth 1 point. And so what we can do is we can create a series of 4 different ordered pairs and relate the place value that you get and the points that you get for that. And so if we look at this, x comma y, and so x can be the place that you get, and then y will be the points that you're awarded for getting that place. So for example, the relationship here is that for first place you get 5 points, for second place you get 3 points, for third place you get 2 points, and then for fourth place you get 1 point. And so what we understand is there's a relationship between this 1 and 5, 2 and 3, 3 and 2, and 4 and 1 that creates this relationship. And so that's really what we're trying to express here with the relationship and with these ordered pairs, is that each ordered pair is a relationship, and then if there's a bunch of them, they're kind of all related to each other in such a way. And there are actually 3 different ways that we can represent relationships, and some of them we're actually familiar with. The first one is a table. And so what we can do is we can put these in a table based on the relationship that they are, and say we have place and then we have points, and then we can pick these things off. So first place gets 5 points, second place gets 3 points, third place gets 2 points, fourth place gets 1 point. And so we can take these ordered pairs, just like we have done before, and start putting them into a table in the correct way. And so it's just a way that we can represent ordered pairs, and we know that we can represent ordered pairs with a table. So as long as we're staying consistent, so all the place values are in one column, and then all the point totals are in another column. It's just one way that we can represent some kind of relationship. And if you notice, we always have a title to this relationship. So this is track scoring, and then we have place and points. The second way that we can represent relationships is with a graph, and we've kind of already done this with graphs before. And so we can graph this relationship based on if this was the place value, and this is the points that you receive. And so we can go ahead and plot these points given that these are kind of xy coordinates on an x and y plane. So first place gets 5 points, second place gets 3 points, third place gets 2 points, and fourth place gets 1 point. And so we can represent these. And this is the idea that this is the relationship of points to place. And from what we know now, this is a discrete graph, because we can't have a half of a place. We'll always have first, second, third, or fourth, and then the given point values. And so that's another way that we can represent relationships, by plotting our ordered pairs onto a graph. And finally what we have is we have what we call a mapping diagram. Now a mapping diagram is a little bit different, but it's basically doing the same thing that we've done before. And so with a mapping, what we do is we always say that x maps to y. And so x is directly influenced to what y will become. And so what we can do is we can put all our x values in this bubble and all our y values in this bubble. So we have first, second, third, and fourth place that we can have. And then we have different values of points. So we have 3 points, 2 points, 5 points, and 1 point that are different y values that we can achieve based on those 4 different given places. And so the idea of a mapping is that we draw an arrow from the x's to the y's in order to show the relationship. So first place is related to 5, so I draw from 1 to 5. Second place gets 3 points. Third place gets 2 points. And then fourth place gets the 1 point. And so the idea is, it doesn't matter how it's arranged as long as it's arranged in such a way, but the idea from a mapping is that the only way to get 5 points is to be in first place, the only way to get 3 points is to be in second place, and all those different things. So just making sure that the arrows from the x column goes to the y column in its appropriate match. And so that's a mapping diagram, which is another way that we can show a relationship. And so now we're going to look at some terminology. So we're going to talk about the domain of a relationship, and we're going to talk about the range of the relationship. The domain of a relationship is the x values. And so the domain is all the x values. And so we take all the possible x values and we say that this is our domain. So for example, what we have is we have an actual number that we use. And so what we're going to do then is we're going to say the domain, which is usually with a capital D, and then we put these little brackets in there, and we say that the domain is 1, 2, 3, and 4. And so the domain just represents all the places. And so the range is then the y values. And so I can write this, well, the R stands for range in a curly bracket, all the values that we have for y, which are 2, 3, 1, and 5. And typically we can write them in any order. It doesn't really make a difference how we write them, as long as each one of them are represented in this bracket. So with the domain is the x values and the range is the y values. Now one thing that I want you to remember is that when we're dealing with domain and range, we only write a specific number once. So if we have a situation where a relationship has more than the same x value, we only write it one time instead of writing it multiple times. So for example, if we had a range of 1, 1, 2, 1, 1, 2, 3, 4, and 4, the actual range would be 1, 2, 3, and 4. We don't write a number more than once. We only write it once each time is represented, because it doesn't really make a difference, and that's why we have the mapping and that's why we have the graph. The domain and range is just to simply show what values of x we have, which values of y that we have. And so what we can do is we can write domain and range based on what type of graph that we have. When we have individual points like this, these are basically what we would consider a discrete graph, because we have very specific points. And so what we do is we use this what we call set notation, and that's exactly what I showed you. So domain and range of this set, so D and R, would be 1, 2, 3, and 4. And then what I have on the bottom is I would use the range, which would be 2, 3, I forgot about 1, so let's put this in order here, would be 1, 2, 3, and 5. And so that would be my domain and range. So I usually use the set notation, which is what this are. Anything that I use this little curly bracket, that's a set. And so we use this for discrete graphs. And now at the bottom we have inequalities, so hopefully you kind of remember a little bit about inequalities, but we're not going to be too worried about that. These are used for continuous graphs. And the idea here is that what we have is, if we have a continuous graph like this that goes from 1 to 2, or let's say 1 to 8, and then from 2 to 9, what we would say is that we have this graph that kind of does this, and it can pretty much do whatever we want it to. And so the domain is the x values down here, and the range is the y values. And so what we do is we look at, okay, well, my x values go from here to here for my graph. And so I would say my domain is 1 to 8, because it incorporates all of those values. And then my range is going to be from 2 to 9, because my graph starts at 2 and then it ends up at somewhere at 9. And so it's all those values in between that I can't really write each individual one out like I can do up here. I can't write out each individual value that lies from 2 to 9, because there's infinitely many that sit there. And so what I can do then is I can just say, well, it goes from 1 to 8 in my x values, and it goes from 2 to 9 in my y values. And so that's how we write domain and range at this point. So set notation we use for discrete, and continuous we use this inequality, or we can kind of write this from 1 to 8. And so if we look at a couple of examples of this, so the first example, this is continuous, so I know I'm going to use this idea that I go from x values at 1 all the way to x values of 5. So those are all my possible x values that lie from here to here. And so the idea, though, if you're kind of having trouble understanding that, imagine shining a flashlight onto this line. And you would think about where the shadow would be. Where the shadow would be from every point from 1 to 4, because the light would kind of just pass through here and pass through here. But here, it's all underneath it. And so we have this idea that if you kind of imagine shining a flashlight there, it would cast a shadow in our domain case. So our domain is from 1 to 5. And then our range, what we can do is then we can move our flashlight to the other side and think about where it would hit on that side. And what it would do is it would cover up 3 all the way up to 4. And so our range here would be from 3 to 4. And then with this mapping, basically what we're doing is this is always domain to the range, or the x to the y. So my domain is all my x's, so I can just write those 1, 2, 5, and 6. And then my range, I can just pick those off too, which is 0, -1, and -4. And then the same thing, I do this with my domain, which is my x's. So I can pick off my x values, which are 1, 4, and 8. And then my range here, I have a 1 and a 1 again. I only write it once. And so 1, 4 would be my range. And so that's basically what we're doing for domain and range. And that's going to wrap it up for this part 1 of section 4.2.